Thank you for watching. My name is Astrid Krasniqi. Today we will be covering CCNA Semester 2, Chapter 4, Routing Concepts. Objectives for this lesson is to configure a router to route between multiple directly connected networks, describe the primary functions and features of a router, explain how routers use information in data packets to make forwarding decisions in a small to medium-sized business network, explain the encapsulation and de-encapsulation process used by routers when switching packets between interfaces, compare ways in which a router builds a routing table when operating a small to medium-sized business network, and explain routing table entries for directly connected network, and explain how a router builds a routing table of directly connected networks, explain how a router builds a routing table using a static routes, and explain how a router builds a routing table using a dynamic routes. Characteristics of network. First characteristic is topology. There are physical and logical topologies. Physical topology is the arrangement of cables, network devices, and end systems. The logical topology is the path over which data is transferred in a network. So physical topology actually describes how the devices and the cables they lay down around your network. Logical topology is how the data travels through those cables. Then we look at the speed. Speed is a great characteristic. Speed is measured of the data rate in a bit per second of a given link in a network. Cost. Cost indicates the general expense for purchasing of network components and installation and maintenance of the network. Then security. Security indicates how protected the network is, including the information that is transmitted over the network. Then another characteristic is availability. Availability is a measure of probability that a network is available for use when it's required. Scalability indicates how easily the network can accommodate more users and data transmissions requirements. So if our network grows, how easy it is to add these extra devices. Then reliability. How reliable is our network? Reliability indicates the dependability of the components that make up the network, such as routers, switches, and PCs and servers. How much can we depend on those devices? They will be there when we need them. Reliability is often measured as a probability of a failure or as the mean time between failures, MTBF, mean time between failures. Why routing? The router is responsible for routing of traffic between networks. So the router's job is to take packets from one network and route them to a remote network or to a different network. Routers can connect multiple networks. Routers have multiple interfaces, each on a different IP network. So each interface on the router has to be on a different IP network. So here I have an example router 1, R1. R1 has two interfaces, FA00 and on the right FA01. Both are connected to two networks. The left network, FA00, is connected to the network 172.16.3.0/24, and we are using the first IP address of that network to give it to R1. Then on the right, FA01 is connected to network 192.168.1.0/24. That's the network ID, and we are using the first IP address of that network to give it to FA01. .10 is the PCs on the left and the PC on the right, .20. To configure the interface on the left, FA0/0, first we have to go to the global configuration mode. After we are in the privilege mode, we type configure terminal to move us to the global configuration mode. Then once we are in the global configuration mode, I know that from seeing the prompt, I type interface and the interface ID, whatever interface I want to connect to or go to start configuring the interface. So in this case, fast Ethernet 0/0, which I'm accessing this interface. Once I'm in that interface, specific interface configuration mode, I type IP address, then 172.16.3.1, and the subnet mask 255.255.255.0. The router's interfaces are down by default, administratively down, so we have to no shut down them to bring them up or enable them. After we have done that interface, we have to move to the second interface, which is this one, fast Ethernet 04/1, by typing interface FA01. Then once we are inside that interface, have a look at these prompts. We see the prompt as config-if, and then in the privilege sign, IP address 192.168.1.1, given address, and the subnet mask 255.255.255.0. So we are configuring this interface. Again, we have to do no shutdown to bring up the interface. Once we configured both of the interfaces and did no shutdown, the router is going to build up the routing table. Now it knows it's directly connected with 172.16.3.0 network and with the interface fast Ethernet 00, which is this side. And it's directly connected with 192.168.1.0, this network, and this interface FA01. So what I'm going to do that now, we are going to see that live on the router. So this is our network, and I have a router 1 here. So in router 1, I'm going to configure. First of all, I'll do is show IP interface brief. As you can see, there's 2 interfaces on this router, fast Ethernet 00, and it's administratively down by default. And the layer 2 information is down as well. Same, that's the second interface, is down as well, which is this interface here. So first thing I need to do, I'm in the privilege mode. I can see that by the sign here. So I need to move to the global configuration mode by typing configure terminal. Now it says enter configuration commands, 1 per line. So as soon as you enter the command, hit enter. I can see the prompt has changed, identifying me that I'm in the global configuration mode. So to access the specific interface, I need to type interface FA00. That is this interface that I'm accessing. Enter. IP address 172.16.3.1 and 255.255.255.0 is my subnet mask. Now interface as we saw is administratively down by default, so we need to type no shutdown, and we should see the interface going up very quickly. You can see that we have some information that says interface FA00 change state to up, and it says everything first is administratively state to down, then it's going to up. So if I do end here to go back to the privilege mode, and I do show IP interface brief again, now I can see the interface, this interface, it's up. That's the IP address that we just assigned, and layer 1 information is up, and layer 2 information is up as well. If I do show IP route, now I can see that I have one directly connected interface, 172.16.3.0, that's the network, and it's directly connected through fast Ethernet 00 through that interface. Okay, now I'm going to try and configure the second interface, FA01, but this time I'm not going to say no shutdown, and we're going to come back and see the problem. So config T, go to the global configuration mode, interface FA01, IP address 192.168.1.1, and the subnet mask /24. I'm not gonna do no shutdown here. Just go to privilege mode again and show IP interface brief. As you can see, the second interface I have configured with an IP address, but I left the no shutdown off. So it still is saying administratively down, and the interface didn't go up. I didn't get these messages that said interface is up. So if I do show IP route, I'm still going to see only one interface, the interface that we did no shutdown, this interface here. Okay, this time I'm going to go to the global config mode, access that interface FA01, and do no shutdown. And then wait a few seconds until the interface goes up, I can see the interface has gone up. Type end to go to privilege mode and show IP interface brief. You can see now that FA01 is gone. Layer 1 information is up and layer 2 information is up as well. So if I do show IP root, I will see more information. Now I see both of the networks. I see the network on the left, and that's my network on the right. Okay, now I'll go back to the slides, and we can see same information. Now, routers are computers. Routers are specialized computers containing the following requirement components to operate. So we have central processing unit or CPU. They need that to operate. They need the operating system. In the Cisco world, we call it iOS or Internet Network Operating System. And they need the memory and storage, RAM, ROM, NVRAM, flash, and hard drive, and the new ones. Now, this is the reason why when we directly connect the PC to a router, we need a crossover cables, because the routers are just like any other computers, just specialized computers. So we have memory, volatile, non-volatile, and what is stored in there. Volatile means that it needs power or electricity to retain the information. Non-volatile means that it doesn't need the power or electricity to retain the information. First memory type we have is RAM, random access memory. On random access memory, it's volatile, so to retain the information, it needs power. In there, we store running Internet Network Operating System, running configuration file, IP routing, and ARP tables, address resolution protocol tables, some packet buffering as well. So remember, operating system is not stored in RAM, but it's running from RAM. It's stored in flash, so when the router loads or boots up, it takes the operating system from flash and it stores it in RAM. So in RAM, it's called running Internet Operating System or running iOS. And configuration file is called running configuration file. Then the second memory type we have is called ROM, read-only memory. ROM is non-volatile, which means that it doesn't need power to retain the information. In ROM, we have boot up instructions, basic diagnostics software, and very important, limited Internet Network Operating System. Now, this operating system will help us a lot in case we lose our operating system from flash, so we can recover our device from this limited operating system. The third memory type we have is NVRAM, non-volatile read access memory, random access memory. Not volatile, from the name, says that it doesn't need power to retain the information. In NVRAM, we store a startup configuration file. So any changes that we make, we have to make sure that we save them. And when they save, they're called startup configuration file. So next time we reload the router or reboot the router, the information that we had or configuration that we had is being stored from startup configuration file, and it will be loaded in RAM, where it's called running configuration file. The fourth memory type is flash. In flash, it's non-volatile. Again, to repeat, doesn't need power to retain the information. And in there we store iOS, Internet Network Operating System. So in flash we store the iOS, but we don't run the iOS from flash. When the router boots up, it will take the iOS from flash and it will load it into RAM, and it's called running iOS in there. In flash we don't see it here, but we have for switches, for example, we have a VLAN database stored here as well. Router choose the best path. Routers use static routes or dynamic routing protocols to learn about remote networks and build their routing tables. So as we said, router's job is to take one packet from one network and send it to another network. So we can learn about these different networks through static routing or dynamic routing. Routers use routing table to determine the best path to send the packets. So if the router learns about some network, it will choose the best path to get to that network and it will add it to the routing table. Next time it needs to send data to that network, it will look at the routing table to make sure which way is the best way, or best path. Routers encapsulate the packet and forward it to the interface indicated in the routing table. So for example, we have here same network that we had earlier, router 1 connected to two networks on the left, 172.16.3.0, and on the right, 192.168.1.0. So when a packet comes in from this PC with .10, the host address, to the router first thing it has to do is look at the destination, where is trying to go this packet, and it's going to check its routing table. Do I have a match for the destination this packet wants? So the destination, it is this PC on the right. So first thing it's going to do is going to look at the routing table. It's going to look at the first entry, which is 172.16.3.0. Since that doesn't match the destination, it's going to go and look at the next entry. The next entry is 192.168.1.0, and that does match the destination where the packet is going. Great. Now once we match the destination, we need to match the exit interface. So where is my exit interface? So fast Ethernet 00. So now the router knows that to forward that packet, he needs to send it out of this interface, FA01. Forwarding packet methods. First forwarding packet method is process switching. This is an older packet forwarding mechanism, still available for Cisco routers. Right, we said that routers, they have the CPU, like any other specialized computers, CPU. Now with process switching, every packet that comes to the router is directed to the CPU. CPU is going to find out destination, exit interface, all that information, done. But now every other packet is going to the CPU, CPU is doing the same job, finding the exit interface, the packet is going. Now this method is very, very slow and is very old. The second method is called fast switching, a common packet forwarding mechanism which is used the fast switching cache to store the next hop information. So the first packet behaves like process switching. Goes to the CPU, finds out the exit interface, and it goes out of the exit interface. But it will keep that information in the memory, so the next packet in the queue or on the flow, they don't bother the CPU anymore because it's on the memory, the exit interface. The third packet forwarding, its preferred method, is a new method and is much more preferred from Cisco, called Cisco Express Forwarding. With the Cisco Express Forwarding, the router builds up the network and the exit interface or adjacency table beforehand. So it does the job before actually packets arrive on the router. So once the packets start arriving on the router doesn't have to bother the CPU anymore because it's already got the table, the pre-built table. Default gateway. To enable network access, devices must be configured with the following IP address informations. So any device on the network, to be able to access the network, needs to have the following information. The IP address, which identifies a unique host on a local network. So for example, let's take the PC on the left here, this PC here. This PC needs, for it to be able to communicate with anyone on the network, it needs an IP address. So we type 172.16.3.10. That's the address, that's the network. Now, what network it belongs to, it needs a subnet mask, which identifies the host network subnet. So in this case, 255.255.255.0, which says the first octet, second octet, and third octet are the network addresses, which matches this one, 172.16.3, and the last .0 is the hosts. Now this PC doesn't need any more information to communicate here on the local network. But if this PC wants to communicate with the PC on the right, it needs a gateway because that PC on the right is on the remote network, different network. So if the PC wants to send any information outside its local network, it needs a default gateway. Now default gateway, for example, for this PC is this interface here on the router 1. So we have to give that 172.16.3.1. That's the default gateway. Now, to configure that, you will go to the control panel and start giving this information. Okay, I have here a PC, a virtual machine, a Windows 7 that is connected to that router. So what I'm going to do here, I'm going to configure an IP address. So to configure the IP address statically, click Start, and then go to the control panel. Once you're in the control panel, click Network and Internet, Network and Sharing Center. In the Network and Sharing Center, click Change Adapter Settings, and then right-click Local Area Connection. After you find the properties of local area connection of the interface card, you have to click Internet Protocol version 4, TCP/IP version 4, and then select Properties. By default, every interface card is configured to be assigned IP address from DHCP, dynamically get the IP address. In this case, we want to give IP address statically, so use the following IP addresses, then type 172.168.3.10. That was the IP address of this PC. Then the subnet mask was 255.255.255.0, and the gateway was 172.16.3.1, and press OK. Click Close again. Now it's trying to identify, and it will get us to the you see, it's identified that we are connected to one network, and on this case I select Work Network. This is just how you're going to set the firewall on the Windows 7. You have to choose one of them. So less strict firewall, medium strict firewall, very strict firewall. Okay, so Work Network. Then I will open the command prompt. So click Start, type CMD to open the command prompt. Then type to verify what we did, which is type ipconfig. I can see that I got the static configuration for IPv4. Sorry, IPv4 here. I got the subnet mask and the gateway as well. Now to see if I can communicate with my gateway, I ping the gateway. So ping. If you ping 127.0.0.1, that is, you ping in your local stack. You ping in your network card. The network card is being installed correctly. All the TCP/IP stack is installed correctly. So you can do that to ping it yourself. Now I'm going to ping my gateway. So ping 172.16.3.1. That was my gateway. And you can see that I have a reply from my gateway as well. Excellent. So this PC is able to communicate with anyone outside its local network. Documenting a network addressing. Documenting is very, very important. So network documentation should include at least the following in the topology diagram and addressing table. You should have device names, interfaces, IP addresses and subnet mask, and default gateways. So for our network, for example, our documentation will look similar, something similar to this. Router 1 is the device name, device. Interfaces got two interfaces, FA00 and FA01. IP address on the FA00 is this. IP address on FA01 is 192.168.1.1, and these are the subnet masks. Plus, we can document for PC1 what interface card you have. For example, Broadcom, I think it is. 10/100 is the speed of the card, and the IP address is using, the subnet mask is using, and the default gateway. Similar information will be for the PC2, switches, and every other devices on the network. Enable IP on a switch. Now, network infrastructure devices, they require IP addresses to enable remote management. For example, the switches, to manage them remotely, we need an IP address. On a switch, the management IP address is assigned on the virtual interface. Now, by default, the switches, they have one interface, one virtual interface where we can manage it. It's not physical. We don't need to connect any cables to it or anything. It's a virtual. It's on the memory. Usually that's a VLAN 1. We give an IP address to that VLAN interface, and we can manage the switch virtually. So, for example, we have this switch on the left, which is layer 2 switch. We can see that from the icon that is using. Layer 2 switches, they don't understand IP addressing or routing by default. So we have to go to one interface, but we have one interface so we can manage this switch. For example, that interface is VLAN 1. First, like the router, we have to go to the global configuration mode, then access the virtual interface. So interface VLAN 1. Once we go to that interface, we can give an IP address. So IP address 172.16.3.100 and the subnet mask 255.255.255.0. Now, we have to make sure that we do no shutdown on the virtual interface, because by default, the virtual interfaces are down on the switch. Now, there's no more configuration we need to do if we want to remote manage the switch from the local network. From here, from this PC, we can manage the switch. But we have, for example, for this switch to be able to be managed from this remote PC somewhere in another network, we have to give a default gateway. So again, global configuration mode, then we say IP default gateway 172.16.3.1, which is this interface here. Now, this PC here can send the telnet traffic, they can manage all SSH traffic to this switch, and this switch will be able to reply back to the PC. To configure basic router settings, basic tasks that should be configured on the Cisco router and Cisco switch. Now, the basic configuration, very important configuration, they are both the same for the switches and for the routers. So first thing, we have to go to the global configuration mode. Once we are in the global configuration mode, any configuration that we do on this mode, they will take effect globally on the router. So like one global configuration would be like the name, host name. Name, we give it because we want to distinguish. We don't have to. We can leave them all the same name as long as you're not using a certificate. But we have to give names if you want to distinguish from switch 1 on floor 1 to switch 2 on floor 2 and so on. To configure the name, we type the command hostname R1, for example. So we can see the default name is router, and we type hostname R1 to get the name R1. Other configuration that we can do in the global configuration mode is the secure management access, like secure privilege exec or user exec modes. And later on we will configure a telnet, but these are not in the global configuration mode. We can encrypt them. All the passwords, they are the ones that are unencrypted by default. We can encrypt them in here in this mode, global configuration mode. First command is enable secret class. This will secure management access. So anytime somebody types enable, they will be challenged with this password. This password doesn't need to be encrypted because it's already encrypted. The next command, service password encryption, is going to encrypt all other passwords that are unencrypted by default, like telnet password, the console password. These are the passwords that are not encrypted by default. So this command, it will go and encrypt them by those passwords. So to encrypt password management access through the console line, we have to go to line console 0, give it a password, passport Cisco. Now this password is unencrypted by default, but it will be encrypted because we have this command here. So passport Cisco, login. What this command does says next time somebody's trying to log on through the console port, use this password, Cisco here. Then we can exit and we go to the virtual terminal lines. So line VTY 0 to 4. So we're accessing 5 lines in total here together. And we say password Cisco and login again. So with this login, we are saying use this password if somebody's trying to remote access. This is local, so this you're going to need a console cable to access through the console port. Locally, you have to be physically close to the router. But this is through the remote access, telnet, SSH, for example, and then you can use the password Cisco. Again, this password as well is unencrypted, but it will be encrypted if you have this command on. Exit to go to the global configuration mode, and again in the global configuration mode we can configure banner. Provides a legal notification for unauthorized users or unauthorized access. So next time somebody is trying to access your router, they will be shown that, okay, only authorized users are allowed, non-authorized users will be prosecuted and so on. So it will help you if you need to take legal action towards somebody who is trying to attack your network. If you don't have this banner, the person who was trying to attack your network is like, well, I didn't know. I thought, and please, 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 please do not use words like welcome or invitation words, because they will work against you in the law. So the attacker will say, well, the word said welcome. I'm trying. I was going in because they will welcome me. So don't use welcome. So use a smart words. Now, some companies, they really get the lawyers involved. It's really important what you put on this banner. The configuration mode is, you have to be in the global configuration mode. Type banner, message of the day, MOTD, then space, then the starting character. This starting character has to match the ending character. So anything between, the router will see as a banner. So the router sees, okay, you started with this character, and I'm gonna wait until I see the same character. When I see the same character, that's it. The banner is done. So don't use the starting character, something like, I don't know, a letter that's gonna appear on the banner. Or, for example, your banner will be just authorized users space, because there's another O, in case if you used O. So try and use one character that's not going to appear on your banner. And then make sure we do save the configuration. So we have to go to the privilege mode and type copy running configuration, or running -config, whatever we are here, running -config to startup -config. So we are copying whatever we have on RAM to NVRAM. So next time we reload the router, the configuration will still be there. To configure an interface on the router, so the router have to have a configured FIDAS address and a subnet mask. We just saw this live on the router, so we went interface FA00, give an IP address, and then you must have activated the interface by using no shutdown commands. When you do that, you will get a message that says change state to up. Serial cables, they do need, the ones that are labeled as DCE, most serial cable that labeled with DCE on the live network are in the ISPs. But if you use back-to-back on the lab, one of the cable will be DCE. The one that is a DCE, you have to configure the clock, because the clocking is very important for it to be able to synchronize the timings. So the DCE, you configure the clock rate as well. And then optional are descriptions. But description is very, very important. You write description, and then a small description what the interface is job, what it's supposed to do. So for example, if another administrator comes in after 6 months, it will know what is this interface, what is it doing, or where is it connecting to. Configure an IPv6 router interface. To configure an interface with IPv6 address and subnet mask, we need to go to the interface and we use IP address, give an IP address, IPv6 address, and then the prefix length. IPv6 doesn't have 255.25, it has a prefix length. And then either we can use link local or other EUI-64. So in our configuration or in our network, we have to go to the router first, and then we go to the global configuration mode and we enable IPv6 unicast routing, because by default IPv6 unicast routing is not enabled. Then we go interface FA00, we access the specific interface and give it an IPv6 address like 2001 column db8 column CAF CAFE column 1 column 1 /64. That's a valid IPv6 address. Now, you know that IPv6 are represented with colon, yeah? Not dots or hyphens or anything. It has to be colon. Activate using the no shutdown. We have to do same with IPv4, we have to do no shutdown. IPv6 interface can support more than one address. In IPv4, we can have one primary address only. So in IPv6, you can configure more than one address. So another configuration address that we can do is link local address. Now, link local address is just like IPv4 or PIPA address, which can connect only to the devices on the local link. And again, we can configure a description.